especially to our Professor Dr. Maurice Del Santos. We are the group 4, and our assigned topic to discuss is all about the hypergeometric probability. And these are the following objectives. First, understand the definition and application of the hypergeometric probability distribution. 2, compute the probability of success in a hypergeometric experiment. Third, identify different types of hypergeometric probability problems. And fourth, analyze and interpret the results of a hypergeometric probability experiment. Hypergeometric distribution. Hypergeometric probability is a probability of obtaining a certain number of successes for a given event in a sample size n from a population of size n containing a known number of success. It is used to calculate the probability of drawing a certain number of successes in a sample of size n without replacements from a finite population containing a known number of successes. The graph of our hypergeometric probability distribution is a bell-shaped curve with the highest probability of success at the mean. The graph decreases as the number of successes deviates from the mean. This report examines the hypergeometric probability of a group of 5 people. The hypergeometric probability of a group of 5 people is the probability of having a certain combination of outcomes given certain criteria. This report will discuss the various factors that can influence the hypergeometric probability of a group.
Okay, so I am Sir Arnel V. Carusali, and I am here to continue the discussion. Okay, first, the size of the group is an important factor. A larger group size increases the probability of a certain outcome occurring. For example, if the group size is 5, then there are 5 possible outcomes, so the probability of getting any one outcome is 1 in 5. Second, the size of the population from which the group is drawn is another important factor. The population size is large, then the probability of a certain outcome occurring decreases. This is because the probability of any one person belonging to a certain group decreases as the size of the population increases. So this is the formula. The capital N stands for the number of items in the population, while the small n, the number of items in the sample. K, the number of successes in the population, while K, the small k, the number of successes in the sample. So let me first, this is the graph of the hypergeometric probability.
Good evening, everyone. I am Mr. Padayaw, so I will talk to you about the example number 1. The problem goes like this. There are 6 white balls and 34 blue balls in a basket. If you draw 8 balls from the basket without replacement, what is the probability that exactly 3 of the 8 balls are white? So the solution for this, we're going to use the formula. So P, probability of X, and then 6 combination of 3 times 34 combination of 5 all over 40 combination of 8. So we are going to use the formula, so we can get the answer for this is 0.07236. So we have the big N, which is 40, N is equals to 8, K is equals to 6, and the small letter K is 3. So the correct answer for this is 0.07236.
All right. So my name is Randall Gorgonio, and that example number 2, I want you to listen to this and pay attention to the next item. Okay. So here, a deck of cards contains 20 cards. 6 red guards and 14 black guards, 5 guards and drawn randomly without replacement. What is the probability that exactly 4 red guards are drawn? Okay, so we all know and we already know what is the formula for this. I want you to just follow the formula and substitute everything. Okay, every given. Okay, you have here the answer. The probability of drawing exactly 4 red guards out of 5 guards drawn randomly without replacement is this. Okay, so you have there P, exactly 4 red guards, is equal to 6C4 multiplied by 14C1 all over 20C5, and you have there the answer. Okay, I want you to take note of that. The answer is 0.1587. Also, you can round it off to the nearest hundreds, okay, if you want to. Do you have any questions so far with our presentation? Okay, that's good. Okay, so let's based from those activity that we have so far. Yeah, I have here another exercise that I want you to answer. Okay, so we have here example or exercise number 1. Okay, this is a problem. Okay, in a factory producing light bulbs, there are 100 bulbs are tested and 10 are found to be defective. Okay, if a sample of 5 bulbs is selected randomly, what is the probability that exactly 2 of them are defective? Okay, I want you to think about this. Okay, so you have there the given 100 bulbs, 10 are found to be defective, and also there are 5 sample being selected randomly, and also exactly 2 of them are defective. So by means of the formula, we can just immediately substitute values, all right, from the K, N, and C. Okay, hopefully that you're actually following with us. All right, here. This is letter A, 0.264, B, 0.464, letter C, 0.003, and letter D, 0.903. Okay. All right, I want you to choose which is the correct answer for this problem. Okay. All right, so that will be, okay, just keep it for yourself. And then you have here example number 2 or exercise number 2. So for exercise number 2, a pharmaceutical company conducted a study and found that 20% of the patients experience a specific side effect after taking a certain medication. If 100 patients are randomly selected, what is the probability that exactly 25 of them will experience the side effect? Okay, so think about it. I'd say you have to create the mathematical sentence from this problem. And also, the most important thing they have to do is to identify first what is being asked in the problem. Okay, so letter A, 0.0077, 0.0553, letter C, 0.0102, and letter D, 0.0836. Okay.
In conclusion, the hypergeometric probability of a group of 5 people is influenced by the size of the group, the size of the population from which the group is drawn, the number of possible outcomes, and the number of trials that are conducted. Each of these factors can affect the probability of a certain outcome occurring.
All right. So that would be all, I think, for our presentation, and we would like to thank our members. All right, so we'll say just a second. Let me check this one. All right, so I would like to thank our members, Janelyn, Zumailo, Angelica, and Ninya, Fatima, Randall, Raymar, and Arnel for the effort that we have actually put in on this work. Okay, I hope you have learned something for today, and that would be all for our presentation. Thank you so much.